Hi, everyone. My name is Tianji. I'm very happy to be sharing how do you Druid to help our business at Stitch Fix. I am a software engineer working on a team called Compute Infra, which is a sub-team underneath data platform. And I will talk about data platform in great detail very soon. So I joined this company around 2.5 years ago. I've been doing small things around Kafka and Spark streaming at the beginning. And then I've been mainly taking care of our Presto and Druid clusters because these were under heavy pressure at the time. And I am currently designing a MetaStore service to help making discovering our metadata easier because it is getting messier over the time. I've been doing similar things in other companies before Stitch Fix for quite a few years, but mainly in the telecom industries. To start the talk, I'd like to talk about what is Stitch Fix. So what is this company is doing? Stitch Fix is a styling service or styling company, which means we buy our clothes, say t-shirts and shoes, and we sell them and make money if we do it well. A special thing about us is if you want to buy from us, you create your profile and then you answer a bunch of questions. And then you pick a day that you're going to get a box of things. And on the day that you picked, when you open your door on your doorstep, you got a box and open it, you'll find out 5 items. And if we do it well, you might realize that, okay, I really maybe like 3 or 4 of them. And this is like surprise and magic for a lot of our customers. And that is the one thing that many customers of us like us. And to be honest, number one reason this company was created in the first place. And behind the scene, what happens is we hire many data scientists and they create models to predict what you are going to like just based on your questions. And then we also hire many stylists. Stylists will use our internal tool. This tool, they type your client ID. And then after that, the tool will return the result that models predict. The models are designed by data scientists and stylists see model results. And the results say listing 100 of items that you may like. And then stylist hand pick 5 and put in a box, ship to you. So we have a good mixture of human and data science for shopping of styling things. So this is our company on the top path that I show on this diagram. So this is good for some customers, but for customers like my wife, she never happy about without seeing things, just buy them. So they just want to see whatever you are going to put in the box before you ship. So for this type of requirements, we actually create the second path. So on the second path, you're going to log into our system, either website or web apps, phone apps, and then you're going to see a list of items. But these items also are created by the models, and then you pick them by yourself. And that's why we call them curated. So they're created by our models. On the top, I'm saying we are a personalized company, so we personalize by using machine learning model. And this is actually just one part of our business. We're saying we use data science for everything. So the stuff I talk about for predicting user preferences are one of the verticals, this. And then we've also got 2 more verticals. The first one is merge. Like we make money by buying things and sell them. So how do we buy? How much do we buy? When do we buy? Where do we put them? These are super important. How do we ship them? These are important. And this is for, so all of these that I talk about are in merge and ops. And then in the middle, we've got other things like marketing. Say, how much do we spend on TV? How much do we spend on Facebook? How much do we spend on email? And for emails, for example, when we send out emails, everyone get their own personalized email. So they, again, emails generated by models. And another special thing about us is we have over 100 data scientists. And every one of these data scientists, they belong to the same organization inside Stitch Fix. And this org is called Algorithm. And if you're a data scientist, if you're interested in looking at how do we use algo to help our business, there's a fancy tutorial here that you can click. So with this many data scientists, how do we support them well? And the founding members of the org, algo org, they wisely designed this abstraction. So they create platform, algo's platform, or we normally call data platform. And the reason we am talking data platform is Druid is inside the data platform. And I work on a team called Compute Infra. Compute Infra is a sub-team of platform. And Druid is used and supported by us on platform. So from this slide on, I'll start focusing on Druid. So I said we're going to use Druid to do things and support our business. Why do we do that? From the very high level, we pick Druid for speed. It is fast, a lot faster than Spark or Presto. And actually, when in our offerings, so at platform, at Compute Infra, we run Spark, Presto, Kafka, Druid. We talk to our customers, or mainly our data scientists, saying, if you run large jobs, use Spark. We don't care your Spark jobs run minutes or hours or days. We support you. But if you want something, randomly ad hoc ways, and you want them to be like short, medium, use Presto. And in our offerings, we actually kill Presto queries whenever they run over 30 minutes. And Druid will kick in if you really need sub-second latencies. So this is super fast for things like you're going to back UI, customize UIs of dashboard. And for this kind of use cases, you want to use Druid. But when we offer Druid, we also say Druid used to have a shortcoming or limit, which is drawing. It is not great for drawing many things in arbitrary ways that other like Spark or Presto offers. I know that we are the Druid community is moving fast, supporting drawings, but at the moment we're still running a version, and we're still talking to our data scientists saying we don't do drawings inside on top of Druid. So if you want to do complicated stuff, you denormalize in your way. I'll show you how very soon. So this is the requirement, speed. And then the special thing about our offering is we abstract things. As I said, under platform, we abstract everything. Spark, Presto, Druid, Airflow, all of them. And in terms of Druid, we focus on two kinds of aspects. One is when you ingest data into Druid, we don't do it. Yes, we run Druid, but we, data platform, we don't do it. We let our customers do it. We create tools or libraries or services for them to use it in a very simple way, simpler than what they normally do when they do their modeling and stuff. And then on the other hand of things, when users or anyone consume from Druid, again, we don't query, we don't consume. Our customers do. I'll go into the details on these two things one by one. But before that, I'd like to dig a little bit deeper into what I just talked about on the previous slide. So on here, I am showing part of data platform focusing on compute infra, our team. Our team is maintaining two types of main things. One is raw data ingestion. So every night, we make snapshots from many Postgres databases, and we move them into S3, which is our data warehouse. And these are files. So we generate files which are in either CSV compressed, the legacy format, And then by default, we're using Parquet right now. And so these are files. And then on top of files, we have Hive MetaStore. So this is the abstraction on top of raw data. When you deal with data in Stitch Fix, you talk about tables because tables are the concept inside Hive. And then on top of Hive, we have Bumblebee. Bumblebee is the service that we create to allow our services, our offerings, say Spark, Presto, to talk to tables. They all talk via Bumblebee. So this is the abstraction on top of files that we have. And then we run 4 major clusters: Spark, Presto. By the way, we're running Trino, the distribution of Presto. In case you know the story in the Presto community, there are 2 versions. So we run Trino, and we also have Kafka for click events. And as I said, we abstract things, so we have services on top of all of these. But because these 3 are not focus of today's talk, this conference is Druid, so I use gray color, and I'm not going to talk more into the services. Rather, I will going to be talking about more on Druid. So on the Druid side, as I said, we've got raw files. So Druid should know raw files somehow. So on this slide, I will talk more later. And then Druid also have to map between table and files. So we've got somehow figure out this. And then we have services. So services basically for 2 things, as I said, ingestion and query. And for ingestion, as I said, I don't do it, we don't do it. Our clients who are data scientists, they use Python. They use Python clients that we create to ingest. And then after ingestion, they are going to consume it in Python or customized UIs, or other partners from other organizations, they can create their own UIs to consume from Druid. The only outlier is Looker. Looker can connect via just traditional JDBC to Druid. But again, the data that Looker can see is ingested by data scientists. And we support all of these using 3 services: Rio, MDF, and Bismuth. And I will going to be talking about them one by one. We have 2 types of Druid clusters. One type called Druid prod, which is for running in the prod environment, and everything else will be in a staging environment. So compute infra is our team. We run Druid. We run Druid in a way that is wrapping and hiding all the secrets or complexities from our customers. So what does it really mean? Let's go one by one. And first on ingestion. We ingest using a very simple tool called Rio. So on the right, I am showing the flow of the Rio logic. So when the user say create a workflow in a DAG in Airflow, and then one of the tasks is for ingesting into Druid, and then they're going to use Rio. Rio will make a call to a Druid middle manager, and then from there, we're going to figure out where is the table. As I said, we use tables everywhere. So where is the table? And from there, map table to actual files. And then tell the EMR cluster that actually doing the ingestion job. Where are the files? And doing stuff using MapReduce. And yes, we're still using MapReduce. Very old-fashioned, but it's super solid and very stable. So using MapReduce, do stuff, and save the result back onto i3. So this is the flow. And so this curve, this here EKS, many of Spark jobs are moving onto EKS very recently, and I will going to be moving ingestion onto EKS very soon. So let's talk about more on the ingestion. So on this page, I am showing a sample Airflow DAG. So this is a real one, but I'm using the random names just for hiding business logic. But anyways, they are two Spark jobs. They're either waiting things and combining things, massage things before denormalization. And Spark 3 and Spark 4, they are really denormalization jobs for Druid. Say in future, Druid support drawings, very nice, very flexible. These two jobs will be gone. But right now, they're still there. I want to tell customers you do this, and then you run MapReduce jobs. When you do that, you use Rio. So this is way like this deck is created by a data engineer, but not me, not our team, any of our team members, by our customers, and they use that by they do that by using Rio. And when they use Rio, they actually just do this. So when they say they want to ingest something, pass resources. So this resource is database.table name. And this is what I said in the Hive meta store. We keep the denormalized table data in the table, and this is the table name. This is where Druid ingestion will read from. And then there are many parameters. Some of them are mandatory, some of them are optional. Like for example, in this use case, again, this is a real one. They don't need a timestamp, but Druid does need one. But we can just put in a random string. But we don't need it, and because we don't need it, we put in random timestamp, and then it tells the real library saying, I'm going to do this in either prod or staging, depending on where I'm going to deploy. And Druid data source is the name that is going to be created or updated in the Druid cluster. And a few others like Parquet by default is Parquet. And this is the tag or name of the EMR cluster that I'm talking about. It doesn't have to be there, it's optional. Okay, I'm going to skip the other parameters. So using with this page, what I'm saying is this is all our data sets our customers are going to do to ingest data. And then after this, they just wait. And then either the ingestion job is succeeded or failed. In that case, we retry until we hit a timeout. I mentioned things around EMR and ingestion using MapReduce. So we are using still using MapReduce 2021, quite old-fashioned. We actually tried using Spark early last year. Somehow the performance is worse than MapReduce. And I like to figure out why, and I like to know whether in the community or by imply where there better offerings. And we also tried using native parallel ingestion, and we realized that it is not easy to scale up and down. Like when I run our EMR cluster, oh, by the way, I forgot to mention, we run our Druid ingestions in its own dedicated cluster. And the reason is this. Previously, we run all our Spark jobs, Druid MapReduce jobs in the same place. But sometimes MapReduce is really heavy. Like they can use up to say 80% of the whole cluster. And then it can use that much resources for say 10 hours. And a lot of people complain like your job is too huge. And the best solution after trying all kinds of stuff is run MapReduce in its own cluster. But doing that can cost money, right? And we scale up and down by load. So when we're not doing any ingestion, we only keep one node running. And then when new ingestion coming in, we scale up, say going to 150, 300. And the jobs are finishing a lot faster now. Like almost all jobs are finishing 1 hour these days. Okay, so this kind of scaling up and down or scalability is important for us because we do the job and we save money. And we're saying hard to scale for native parallel. What I'm saying is I didn't realize, or at least we didn't figure out how to do that properly. Maybe there are mature solutions now. and I'd like to find out how. And I said earlier that we're going to try to move into EKS in the container world, Kubernetes world, rather than using EMR. And it will be more cost effective from some sense because those jobs will be sharing the Kubernetes cluster. Okay, and now I'm going to talk about how do we query Druid. Again, so query is the job that we leave for our use cases, for our data scientists, and they create use cases whenever they see fit. And if the business feels like the number of data scientists are not enough, they can hire more. So platform does not change. They're going to create more things on top of it. And there are also two paths. One is Druid SQL and then RESTful APIs for querying. Druid SQL will be mainly used by our data scientists. They use Python, so we create a simple library called SF, PyDruid. Use this simple library. They make calls via the Druid SQL path, and then we give them back data frame, pandas data frame, because that's the number one thing that data scientists need. And they can use this as a PyDruid library either in notebooks or Python apps, any ways they want. Or if they have other apps running in containers, they may want to consume things in the second path over RESTful APIs. And this is where we have two new services that I'm going to introduce from the next slide on, MDF and Bismuth. I will talk about them very soon. So our data scientists create data and put on them, and they can consume where these two paths. And also we have business partners from, say, marketing, merch buyers. They can consume from our customized UIs. And these customized UIs will likely hit our Bismuth service. And the outlier, as I said earlier, will hit Druid directly. So now let me focus on MDF and Bismuth. MDF is a abbreviation for metrics and dimensions foundry. So this is a service that is created by a previous colleague, and it's maintained by a team. And the reason we're creating this centralized matrix is, oh, by the way, this matrix is not Druid matrix. This matrix is Stitch Fix specific matrix. All the metrics that we're going to use in MDF are Stitch Fix only. The reason we're creating centralized matrix is this. Say you've got a group of people creating business definition success rate, which is, say, the number of sold t-shirts divided by large size large plus size medium, and one group defines this. Another group may divide t-shirt divided by small, and then they will find out the discrepancy maybe later downstream. And in that case, things are very complicated. It is very hard to figure out what is actually going on. And this is the number one reason that we're creating this service. So it's more or less like in a producer and consuming world, we make MDF so that only one producer generating data and all the others are reading. So we don't have conflicts anymore. And this is the reason MDF is created. And inside MDF, users are going to define metrics, again, Stitch Fix metrics in YAML files. And then there will be a MDF compiler. You run it against these files, and they will generate two types of things. One is Spark SQL code in files, and another Druid rules. Spark SQL code will be picked up by Spark jobs and run, and then generate tables, have metastore tables, and then save onto S3. After that, all of these tables can be shared, read by two type of things. One is across all compute clusters, Spark, Presto, Druid, anyone can consume, so centralized, and also across organizations. Any org can consume this type of table. Sorry. All right, and then the second type of thing is Druid rules. So as I said, metrics in MDF are state fixed metrics, but how do we query Druid? So this is where the rules come in. We have a second service called Bismuth. Bismuth is the gateway that does the translation. So you send MDF queries to Bismuth, and Bismuth translate for you, and then Bismuth will make sure that the query is going to Druid, it's Druid queries, and it's valid. And they do that and get the results and send back to you. And this slide, I am showing a sample Bismuth query or MDF query, either way. So I'm using curl on an endpoint. I'm saying I'm going to execute this query. In here, we have metrics. There's only one. By the way, this is again a real query. So there's only one query, and I'm using a random name, a metric name. And then I'm saying I want 2 dimensions. And I'm saying I'm going to filter by the 3rd dimension. And granularity is a thing that we create for us. Fiscal week. So this is again stage fixing. We have fiscal week, fiscal month, fiscal year that is not matching the calendar date, and other optional parameters. And the last one is table name, a data source name. So this one is also optional. If you say this, it is going to only query this data source on Druid. If you leave it out, MDF and Bismuth will figure out which data source, the matrix and group by or dimensions will exist. So this is Bismuth. Now, at the end of my presentation, the title of my talk is Flexible Decision. So what do I actually mean? I mean 2 things. One is we data platform are in the middle. So we run Druid, we create services, tools for customers to use, but they don't feel us. We don't create use cases. We don't query things. It's all depend on you customers. If everything we do is correct, they don't feel like we're in the middle, even though we are actually in the middle. And this is super flexible. And this is the number one, like a major Druid customer keeps saying, this is so flexible. We can do things without anyone. We add matrix, we create dimensions, we change things all the time. They just like it. So this is one aspect. And the second angle that I'm saying things are flexible is really offered by Druid itself. The speed of it is just super fast. Sub-second latency, even and you do slicing dicing for a huge number of dimensions, like in one of our use case, sample use case. We have over 300 dimensions and probably 50 metrics in a single data source, and this is having big dollar impact on our business. But I really hope I can demo it, but it's very easy. But they are actual dollar numbers in it, and I'm not supposed to be showing it. The idea is this: like we buy and sell, and we make money in between, right? So buying thing is super important. Like how many do we buy? T-shirt or what? When do we buy? Which geolocation we're going to put them, and how do we ship them? These are super important decisions. Our buyers are using Druid to make all this kind of decisions every day, every single second. Maybe while I'm talking, the slicing dicing, clicking around, and on the same page, there are hundreds of queries hitting a Druid cluster, and they're making decisions right now. Okay, this is it that I'm going to talk about, and I certainly welcome any questions that you may have. Thank you.
Yeah, feel free to enter any questions you might have in the Q&A sidebar, and we'll make sure we read them to Tanji to get your answers. Can you talk more about MDF? Is it an open source project?
It's not open source. It's a service that is created and maintained by our data engineering team. As I said, it's a complicated thing and it's tightly integrated with our business. The major users are doing this is, so they're really defining specific business metrics. And then what we do is we just convert these metrics into Druid metrics, and then send the queries over.
Sure. Thanks you for that answer.
Mm-hmm. Thank you for asking.
And I'll push aside the same one, fella. Are you evaluating joins in Druid?
We will be doing, so after finishing my current project, I'll be doing a few more things on Presto and Druid. On Druid, I'm going to do two things. One is ingestion. So ingestion using MapReduce is really old-fashioned. I am really hoping we can do things better. And in terms of drawings, I will definitely evaluate, and I'll make sure that I've seen other people talking about the pros and cons of current drawings in Druid. I think I really like to see more than one algorithm supporting drawings, and then a big fan of push down. So if they're pushed down, I'll definitely do it. So I will definitely evaluate drawings for sure. Thank you. Great question. It looks like no more questions. Patrick, do you think we can?
Yeah, we can
All right.
end it. Hey, thank you very much. That was a great presentation. Appreciate
Thank
it.